Hello everyone. Tomorrow we are going to be having our Unit 1 test. So today we're going to review the past couple topics that we've covered, which is arithmetic combinations of functions, compositions of functions, and inverse functions. So let's get started from the beginning. First problem says, given f of x equals 2x squared minus 7x plus 5, and g of x equals x minus 1, find f plus g of x. So here, all they want you to do is add the two functions. So if I had, this is function f, parentheses, plus function g. Okay, the good thing about plus is that even though it has parentheses, all you need to do is combine like terms. So this is the only term that has x squared, so that's going to stay the same. Then I have two terms that have x's. I have minus 7 and plus 1, so that would give me minus 6x. And then I have two terms that are constant. I have a plus 5 and a minus 1, which gives me plus 4. Okay, the next problem. So given it's the same two functions, f of x and g of x, this time they want us to find f minus g of x. So I'm going to rewrite it. Here is f of x, which is 2x squared minus 7x plus 5. Subtract, parentheses, x minus 1. Okay, so with subtraction, there's an extra step in that you have to distribute the negative sign. So the minus counts as a negative, and you need to distribute it to everything in that second parentheses. So the first one is going to stay the same for now. I'm just going to rewrite it. But on that second set of parentheses, I have negative times x would be negative x. And then negative times negative 1. So negative times a negative makes that positive. Okay, and then now we combine all of our like terms. So I only have one term that's squared. That's going to stay the same. I have two terms that have x's. So I have negative 7 minus 1 is going to give me minus 8x. And then I have two constants. So I have positive 5 plus 1, which would give me plus 6. Okay, our next problem says given f of x equals 2x minus 1 and g of x equals 2 plus 3x, evaluate f plus g at negative 3. So if you notice on the first two problems, it told us it had an x here. So all we were working with was the function. But in this next problem, it actually gives me a number. So not only am I going to have to perform that addition, they want me to plug in negative 3 once I'm done. Okay, so first let's do that addition. So that would be 2x minus 1 plus 2 plus 3x. Okay, so let's combine our like terms. I have 2x plus 3x, which gives me 5x. And then I have negative 1 plus 2. So that'll give me positive 1, so plus 1. So that's the function f plus g of x. But they wanted us to evaluate at negative 3. So I'm going to take the function that we just found, 5x plus 1, and I'm going to plug in negative 3 where the x is at. And when I do that, I get negative 15 plus 1, which is negative 14. Okay, the next problem. Given f of x equals 2x squared minus 7x plus 5 and g of x equals x minus 1, find fg of x. So when they're next to each other like that, all they want you to do is to multiply. So in class, I believe we did just distribution, but I want to show you box method just in case you like that better. So when you multiply, I'm going to make a box. Only my box is going to be a rectangle this time. And you know how many windows to make by however many terms your functions have. So since the first function had 1, 2, 3 terms, that's why I made 3 columns. So f of x, I'm going to write it around across the top. 2x squared minus 7x plus 5. Okay, and then g of x, I'm going to write it down the side. X minus 1. So let me zoom in a little so we can see better. Now I want to multiply corresponding columns and rows. So here on the top left, I have 2x squared times x, which gives me 2x to the third power. Right below that, here, I still have 2x squared, but now I'm multiplying by negative 1. So all that's going to do is turn it negative, 2x squared. Okay, now the second column, negative 7x times x. So that's negative 7x squared. And then right below that, I have negative 7x times negative 1. Negative times a negative gives me positive. So this would be plus 7x. And last column, 5 times x gives me 5x. And 5 times negative 1 gives me negative 5. Okay, so now that my box is all filled in, I am going to combine like terms just looking at that box. So in that little kind of window thing, there's only one term that has x to the third power. So that's going to stay the same, 2x to the third power. Okay, then I want to combine anything that has to the second power. So if you see this box and this box both have x to the second power, so I can put those together. And that's negative 2 and negative 7, which together would make negative 9x to the second power. Okay, next I have plus 7x and plus 5x. So again, I'm putting those together, and that gives me plus 12x. And then last, that minus 5 is the only constant, so it's going to stay minus 5. Okay, and that's my answer for f times g of x. Okay, next problem. Given f of x equals 2x squared minus 7x plus 5 and g of x equals x minus 1, find f divided by g of x. So when you're dividing, you can set it up as a giant fraction. So since f is first, f would be on top. 2x squared minus 7x plus 5 divided by g of x, which was x minus 1. So when you're dividing, there's a few methods. You can do long division, synthetic division, or you can try factoring. In this case, you're going to be able to factor, so that's what we're going to do. So looking at just the numerator, I want to factor that quadratic equation. So I'm going to work it out to the side here. So just the numerator. Where do I start when I want to factor? So I'm going to make myself kind of a T-chart here. And on the left side, I want AC. So what that means is the first number multiplied by the last number. So that's 10. I'm going to find all my factors of 10, and the goal is to have it equal b, which is that number in the middle, -7, when I add them up. Okay, so let's go through the factors of 10. I can do 1 times 10, or I can do 2 times 5. The thing about positive numbers, though, is that you could also think in terms of negatives. So what if I had -1 times -10? Well, a negative times a negative makes a positive. And then what if I had -2 and -5? So same thing, 2 times 5 is 10, negative times a negative makes it positive. So I have 4 choices to pick from here. Which one of these, when I add it together, is going to give me -7? So the first one gives me 11, that's too high. The second one gives me 7, but that's a +7, and I'm looking for negative, so it's not that one either. Third one gives me -11, so not that. The last one gives me my -7. So I'm going to use the numbers -2 and -5. So when I do my factoring, x minus 2, x minus 5. Okay, but at the beginning, see how I have these little arrows here? Since I multiplied those two numbers, since I had to multiply by 2, I have to undo that by dividing by 2. Okay, then you simplify as much as you can. So in that first factor, 2 divided by 2, well, that's just another way of saying 1. On that second factor, 5 over 2 doesn't simplify, but we do not want to leave it as a fraction. So what we do is we get this bottom number and we move it in front. So this would turn into 2x minus 5. So this is not our answer yet, but this is going to help us. So I know that that's the factored form of the numerator of what we were doing. So basically that's f of x, but I just factored it. So if I go back to my problem and I'm doing my dividing, on the top, I could rewrite it as x minus 1, 2x minus 5. Then at the bottom, I still have g of x, so I still have x minus 1. Okay, and then from here, I'm sure you guys can see it. There's something that's on the top and on the bottom. So when you have it both on the top and the bottom, that's the same thing as 1. So you don't need to write that part. So that just equals 2x minus 5, which is our answer. Okay, so this was all the arithmetic combinations: adding, subtracting, multiplying, and dividing, and also any one of these. So I did addition. They could always ask you to evaluate at a certain number. So you have to perform whatever operation they want you to do and then plug in the number they give you. So my example was for plus, but on the test it could be any one of these. It could be minus, it could be multiply, it could be dividing. Just know at the very end, that's when you plug in the number that they want you to evaluate for. Okay, the next thing that we covered was function composition. So number 6 says, given f of x is 3x squared minus 1 and g of x is 2x plus 3, find g of f of x. So remember, whatever letter you see first, so on this one, they have g first. You're going to start with that function, g of x, and you're going to plug in the other function into it. So f of x would go inside of it. Okay, so let's do that with the functions that they gave us. So starting with g of x is 2x plus 3. So I'm going to write 2, but instead of x, I'm going to leave a space, plus 3. Okay, now within that space, you're going to plug in f of x, which is 3x squared minus 1. So that is just us setting up the problem. Now I want to actually work it out and simplify it as much as I can. So this 2 outside of the parentheses, that can get multiplied in. 2 times 3 gives me 6, but it's x squared. And then 2 times negative 1 gives me minus 2. And then that plus 3 at the end, it's not inside the parentheses, so I don't need to multiply it, but it does need to come down here. So now that we distributed and our parentheses are gone, I need to combine my like terms. The first one, that's the only term that's squared, so it's going to stay the same. I'm going to write it over here to the side. But the second two are both constants, so I can put them together. So negative 2 plus 3 would give me positive 1. Okay, the next problem, it's still the same functions if you look carefully, see that? But this time they want us to go the other way around, so f of g of x. So on this one, since f is the first letter that you see, we need to start with that function. And then inside of it goes the other one, so g of x would go inside of it. Okay, so let's do that with our functions. So since we're starting with f of x, I need to start with 3x squared minus 1. Only I'm going to replace the x with a set of parentheses. Now inside that parentheses, we're going to plug in our other function, which is 2x plus 3. Okay, now we want to simplify this as much as we can. This one's going to be a little bit longer than the first one because I have a binomial being squared. So we need to do either box method or FOIL, whatever you want to do. So I'm just going to rewrite this because anytime I have something squared, I know that it's there twice. Okay, but now I want to do that multiplication. So I'm still going to have that 3. And this is still going to be in parentheses. But let's multiply this out. So if I do distribution, I have 2x times 2x. That gives me 4x squared. Okay, then I have 2x times 3, which gives me plus 6x. Now the second term, 3 times 2x gives me plus 6x. And then last, 3 times 3 gives me 9. Okay, now I want to distribute the 3 that was out front. So 3 times 4 gives me 12x squared. 3 times 6 gives me 18, and it's there twice. And then 3 times 9 gives me 27. And then I still have that minus 1. I'm just going to bring it down. And now that my exponent's gone, my parentheses are gone, now I can combine like terms. So I'm going to write my answer to the side. Okay, there's only one term that has x squared, so that's going to stay the same, 12x squared. Then I have two terms that have x's. I have 18 plus 18, which gives me 36, so 36x. Then I have two constants, 27 minus 1, which is going to give me 26. Okay, so that is the composite function f of g of x. So notice that even though it was the same functions for number 6 and number 7, it's the same functions, doing your composition in a different order gave you two different answers. So be very careful with what letter you put first, because if this is a multiple choice test, both answers are going to be choices. Okay, and then the last thing we talked about were inverses. So I just want to practice finding the inverse. So number 8, find the inverse of f of x equals 3 parentheses x plus 4, then minus 1. So the first step is to replace that f of x with a y. Okay, so I just rewrote it with a y. Second step is to flip the x and the y. So this is going to turn into x equals 3 parentheses y plus 4, then minus 1. So notice that the y moved here and the x moved here. They traded places. Okay, and then now you want to solve for y. So I'm going to start by adding 1 to both sides. So that gives me x plus 1 equals 3 y plus 4. Okay, so since the 3 is right next to the parentheses, that means that it's multiplying. So in order to move it over, I'm going to divide. So I'm going to write this to the side so I could have space again. Now I have x plus 1 over 3 equals y plus 4 because the 3's canceled each other out. And one last step, I would subtract 4 from both sides. But that 4 is not going to be part of the giant fraction. It's going to be separate. Okay, so now y is all by itself. So you are done. This is the inverse function already. But we need to write it in inverse function notation. So you're going to write f with the little -1, that's the symbol for inverse of x, equals what we just found. Okay, and then one more time. Let's find another inverse. Find the inverse of g of x equals 2 parentheses x minus 7 squared plus 5. Okay, so I know it's g of x, but it's still the same thing. You're going to replace that with a y. And then your x and your y are going to trade places. So x equals 2 y minus 7 squared plus 5. Okay, so we want to solve for y. So the first thing you could do is subtract your 5. So x minus 5 equals 2 parentheses y minus 7 squared. Then the 2 that's in front of the parentheses, I want to divide that out. So now I have x minus 5 over 2 equals y minus 7 squared. Okay, now I need to get rid of that squared. And the opposite of squared is square root. So we need to do that to both sides. And that leaves us with the square root of x minus 5 over 2 equals y minus 7. So last step is to add 7 to both sides. But that 7 is not going to be inside the square root. So I have square root of x minus 5 over 2. I made that radical a little bit long, so I'm going to erase a piece of it. Okay. Then plus 7 on the outside equals y. So now we're done. Y is by itself, but we're going to write this in inverse function notation, and they originally used the letter g, so I'm going to keep using g. So this will be g inverse of x equals the square root of x minus 5 over 2 plus 7. Okay, and that's everything that's going to be on the test tomorrow. It will be mostly multiple choice, just the way the quiz was, but there's going to be 2 questions at the end where I ask you to show your work. But everything that you need to know for this test is very calculation heavy, so basically any one of these could be one of those working out. But I would pay special close attention to function composition. That is most likely going to be one of the ones I ask you to show your work on. And probably one of these, finding an inverse. Okay guys, if you have any questions over anything, just send me an email and I will try to get back to you as soon as I can. And tomorrow on Friday, we will be having our test. Okay, bye.